let's look at a few more advanced examples for solving exponential equations. So let's start with 3 to the x plus 2 times 3 to the x is equal to 81. Now, the first giveaway is same rationale as we saw in the more basic examples. We want the bases to match. Because I see 3 on the left and an 81 on the right, I'm going to try to get the 81 to match the 3. And we do that by rewriting the 81 as 3 to the 4th. Now, we did not have a mechanism for solving this when there were 2 iterances of the variable, but that's where our understanding of the exponent laws come in. If I am multiplying together 2 expressions that have the same base, I'm going to add the exponents. And I can rewrite that left-hand side as having a singular exponent on a singular base. 3 to the 2x plus 2 is equal to 3 to the 4th. Because these bases match, I can now write an equation that sets the 2 exponents equal to each other. And I solve, and I get that x is equal to 1. If you back check that answer, this becomes a 3, that becomes a 1, and that is all multiplied together to make 81, so that works. In our other example, we're going to have to engage a few more skills from this course. So in this example, we have 3 to the x squared minus 12 is equal to 9 to the 2x. First, we want the bases to match. The easiest way to do that is take whatever the larger base is and try to rewrite it as the smaller base. And because that base is a 9, that is not a horribly complicated process for us. We're just going to write it as 3 squared. And don't forget the 2x that was already there. The power to the power on the left is going to be rewritten as 3 to the 4x. The power that's on the left, the power that was on the right, 3 to the 4x. The power that was on the left, we're not going to separate this. We want it to be 1. That's what we saw in the last example. We don't want to try to rewrite this so that it has two bases and 2 exponents. We're good with 1. Because the bases are the same, we know that these two have to be equal. So x squared minus 12 is equal to 4x. And this is what we saw in our polynomial factoring / solving units, where we rewrote this, set equal to 0, and we either use the quadratic formula or we factor and solve. I will tell you that the majority of these kinds of examples will be set up so that you will be able to factor them. Because that's not the point of this solving. That's not the goal of this. The goal of this is, did you remember to set it equal to 0 and see that this was a quadratic? So more often than not, if this was to occur in a homework problem or a test question or something like that, in a more sophisticated scenario, you're going to look for that to factor. And typically it will come out to be something relatively easy to factor. And here we have 2 solutions. And if we back check both of them, they both are operable. So, moral of the story, exponent laws still matter. We're not ignoring all of those things that we saw earlier this year and in previous courses. Exponent laws still matter, and the goal is the same. Match the bases so that you can take the exponents and use them to write an equation.